Hi, this is Leetcode question. Minimize the maximum of two arrays, and this is the third question of bi-weekly contest number 94. So we have two arrays, array 1 and array 2, which are initially empty. You need to add positive integer to them such that they satisfy all the following conditions. Array 1 contains unique count 1 distinct positive integer, each of which is not divisible by divisor 1. Array 2 contains unique count 2 distinct positive integers, each of which is not divisible by divisor 2. The third condition is no integer is present in both array 1 and array 2. Given divisor 1, divisor 2, unique count 1 and unique count 2, return the minimum possible maximum integer that can be present in either array. For example, here we have divisor 1 equal 2, divisor 2 equal 4, unique count 1 equal 8, unique count 2 equal 2, and array 1 has this number 1, 3, 5, 7, 9, 11, 13, 15. The number of these numbers is 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 numbers in this array, and this should equal to unique count 1. So we have 8 unique numbers in this array, and every number in this array is not divisible by divisor 1, which equal to 2. So 1 modded 2 is not 0, 3 modded 2 is not 0, 5 modded 2 is not 0, 7 mod 2 is 2 is not 0, and so on. And so array 1, so this array 1 meets the first condition, which is contains unique count 1, and each of which is not divisible by divisor 1. And array 2 also has 2 elements which equal to unique count 2. So we have 2 unique elements here, and every element is not divisible by 4. So 2 model 4 is not 0, 6 model 4 is not 0, and so array 2 meets the second condition. Now no integer is present in both array 1 and array 2, and as you can see here, every integer here is not in array 1. So 2 is not array 1, 6 is not in the array 1, and so the third condition means we need to return the minimum possible maximum integer that can be present in either array. In this case, the maximum number in the two arrays is 15, and so the answer for this example should be 15, and this is the minimum number that we can use to create two arrays such that these two arrays meet these 3 conditions. Now how can we solve this question? First of all, to have the first condition, array 1 contains unique count 1 distinct positive integer, each of which is not divisible by divisor 1. So assume the maximum number in the array is x. So the number of numbers that are unique and they are not divisible by divisor 1 should be x 2 divided by 2, x minus x divided by 2. For example, if we have the number 15, so the number of elements that are divisible by 2, so the divisor equal 2. So the number of elements that are from 1 to 15 that are divisible by 2 equal 15 divided by 2 equal 7, and the number of elements that are not divisible by 2 equal to 15 minus 7 equal 8 numbers. So assume we have this number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have elements from 1 to 15. The number of elements that divisible by 2 is 7, which are 2, because 2 modded 2 is 0, 4, 6, 8, 10, 12, 14, and so we have 1, 2, 3, 4, 5, 6, 7 elements divisible by 2, and the remaining are not divisible by 2, which equal 8, and these numbers are 1, 3, 5, 7, 9, 11, 13, 15. And so for the first condition to meet, so the number of numbers that are not divisible by divisor 1 should be x minus x divided by 2. 2 is the divisor 1. And for array 2 contains unique count 2 distinct positive integer, each of which is not divisible by divisor 2. So the number of elements in the second array that are not divisible by divisor 2 equal x minus x divided by divisor 2 equal 4. So this is for the first condition. This is for the second condition. For the third condition, no integer is present in both array 1 and array 2, and so the numbers that are divisible by both divisor, so here we have divisor 2, we have divisor equal 4, 2 and 4. So we need to calculate the least common multiple of these two numbers, and in this case it's equal to 4. So for example, if we have 2 and 3, the LCM will be equal 6, which is the least common multiple of these two numbers. And so any multiple of this number will be divisible by both 2 and 4. So for example, 4 modded 2 is 0 and 4 modded 4 is 0. If we multiply this by 2, become 8. 8 modded 2 is 0, 8 modded 4 is 0. Then we have 12. 12 modded 2 is 0, 12 modded 4 is 0. Now 16. So every time I add 4, or here I multiply by 1, 4 multiply by 1, here 4 multiply by 2, now 4 multiply by 3, this 4 multiply by 4, so this is 16, and again 16 is divisible by 2 and 4, both divisor. And so to meet the third condition, the number of, let's say we calculate LCM and LCM of divisor 1 and divisor 2, which equal to 4. Let's call it G also. So x minus x ala G, or 4, should be greater than or equal the number in two arrays which is unique count 1 plus unique count 2. Here as we said, for condition 1, the number of elements that are not divisible by 2 is x minus x2 and should be greater than or equal unique count 1. And for array 2, this should be greater than or equal to C2. So we need to find a number that can meet these three conditions: this one and this one and this one. If we found such x, that will be our answer, and it should be the minimum. So in this example, we keep iterating. We will use binary search until we reach the minimum number. So for example, if we take number like 10, so 10 for the first condition minus 10 divided by 2 equal 5, and this is less than unique count 1, so this number is not good. If we take 14 minus 14 divided by 2 equal 7, and this is also not sufficient. We need 8 unique integer. If we take number like 17 divided by or 17 minus 17 divided by 2 is equal to 17 minus 8 is equal 9, and this is good number which is greater than or equal count 1. Now for the second condition, 17 minus 17 divided by 4, which is divisor 2, which equals 17 minus 17 divided by 4 equal 4, and which equal 13. So there is the 13 numbers from 1 to 17 that are not divisible by 4, and we need only 2, so this is also good. Now we need to check the last condition. First of all, we need to do LSCM between 2 and 4, which is 4, and we need to find the numbers of elements that are not divisible by 4, which equal again 13, and this number is greater than or equal count 1 plus count 2. Count 1 is 8, count 2 is 2. This is greater than or equal 10, so this also meet. So this 17 is an answer, but we need to find the smaller, so we need to check for a smaller number. So for 15, and 15 also will meet all these three conditions. So in that case, we check 14 doesn't, so 15 is the minimum value, and we return the answer. Let's look into the implementation. So here G equal the LCM of divisor 1 and divisor 2. Time complexity of this is log of the minimum of these number. And here we have while loop, in which we will do the binary search. The left start at 1 and the right is the greatest value, 1 to or 10 to the power 10. So while left is less than R, we do this. We find the middle it is L plus R divided by 2, and here we calculate the first value. Here this is the first value, x minus x2, which is m, the middle, minus m divided by divisor 1. This is the second value, which is m minus m divided by divisor 2, and this is the third value. We use the LCM and we check the three condition. V1 should be greater than or equal unique count 1, value 2 should be greater than or equal unique count 2, and value 3 should be greater than or equal to count 1 plus count 2. If these three condition meets, we store it into answer, and we set the right equal to the middle to see if we can find smaller answers. And here we break our loop if m, the current middle, equal previous middle. So in each loop we store the previous median, and this is just a way to implement binary search. So I quit the loop. Let's say we have 3 plus 4 equal 7 divided by 2, 3. So next loop we have 3 plus 3, 6 divided by 2. Again, it's the same number, so this number already checked, and we break the loop.